So we've talked about some of these weird moons of Saturn. Well, we're not done yet. Iapetus. One side's dark, one side's bright. Now, when you see something like this, the first thing you think is, well, the sun's shining on one side, makes it bright, and the other side's in the shadow, making it dark. No, that's not what's happening. It's not the shade here that's doing it. Literally, one side is more reflective than the other side. And so the leading hemisphere is dark. So as it's going around the planet, this is the front side of it right here, and this is the back side of it right there. And so the trailing hemisphere is lighter. And so what's going on here? Well, the first guess is that possibly that there's some kind of geologic activity going on it that's releasing something bright onto one side or something dark onto the other side. So that's your first guess. Turns out that's wrong. Turns out that the reason that it's that way is a neighboring moon, Enceladus. And so Enceladus is kind of odd. You do have part of the moon which is got craters on it, but normally a lot less craters than we normally see with the other moons. The other part has very few craters, has fissures and cracks in it, and it's kind of smooth. Now, smooth is important because smooth means it's been resurfaced. Well, what can resurface it? Well, volcanic activity. Well, this moon is actually too small. There's too many other things out there. Too few other things out there pulling on it, so there's no tidal heating on it the way that Io and Europa and so forth were warmed up around Jupiter. So that's gonna not make it molten inside. And so what are we talking about? Well, by volcanic activity, this is also what we call cryovolcanism, not liquid rock, but liquid water. So at this distance from the sun, water is frozen solid, so it's frozen like a rock, and if you heat it, it becomes liquid, and then it comes out into the surface and freezes like a rock. So what this is suggesting is we have water volcanism, that something is heating up the interior to the point that water emerges onto the surface and freezes. So water is taking the place of magma in this case. Now the problem is the moon seems to be too small to be heating up enough to give that kind of effect. So we look at it closely from the spacecraft that have looked at it, and of course the Voyagers just flew by and took a few pictures and realized it was weird, but the Cassini spacecraft has orbited Saturn for quite a while before it finally died, and so it flew by several times and got much better resolution images. And we see, no, these are actually definitely recent fissures and ridges, that this is geologic activity, not something else. So this does suggest cryovolcanism. Now the thing is, this is very similar, particularly in the southern part of Enceladus, to what we have seen on Europa. Remember, on Europa, one of the moons of Jupiter, that we saw the evidence of liquid water under the icy surface. So this would suggest there's liquid water under the icy surface of Enceladus. Again, this is not something we would expect because this moon is too small to retain heat from formation the way a bigger planet would. The moon does not have other big moons nearby pulling on it the way that the Galilean moons did. Io and Europa, and to a lesser degree Ganymede, were caught in this tug of war. Callisto was in there too, but it's really far out, so it had least effect. But those were all caught in a gravitational tug of war that stretched and squeezed them, which generated heat. That's not present here. There are not enough big objects here pulling and stretching and squeezing to do the same thing. So that's not going to do it either. What else is happening here? Well, there was electrical heating that happened on Io, caught in the huge gravitational field. Well, Io was the closest innermost moon, and so that that magnetic field, not gravitational, but magnetic field was so intense that generated electrical energy that heated it up like an electric heater. That's not going to work here either. So what's going on? Well, the other weird thing was that the Cassini spacecraft noticed there's like an icy Taurus here. So remember the plasma Taurus around Io's orbit? Well, there's this icy Taurus, like snowflakes going around. And where is that coming from? That suggests maybe that these volcanoes were spewing stuff out, kind of like the volcanoes were spewing stuff out on Io, except instead of a plasma torus, it's making like an ice torus with tiny little ice crystals. And eventually, the Cassini spacecraft managed to catch a picture right here. And the picture showed a plume of stuff coming out from the southern hemisphere. Cassini spacecraft saw this, and then late in its mission, at risk of damage to the spacecraft, they intentionally flew through the plume to gather some information about it. It was never designed to fly through a plume, and it had no instruments really specially made to study that. They just were hoping to get something. And in fact, they did find some interesting things there, indicating that that plume was not just water vapor. Yes, it was water vapor, but it had some organic molecules in it. Well, again, organic molecules just means carbon and maybe some mixed with nitrogen, oxygen, hydrogen, and some other sort of things similar to what we expect, to find in comets. So that doesn't necessarily mean life. Organic, in this case, doesn't mean life, but these kind of molecules are the building blocks which you expect to have in life, and there may be liquid water. So the other thing they realized was that all of this cryovolcanism spewing stuff out like big geysers of water is what gave rise to the outermost of Saturn's rings, the E ring. And all those icy particles in that E ring were what were splattering onto the other side of that one moon, Dione, which is one side's bright and one side is dark. And so now we have an explanation as to why that would be the case. Again, back to here. Now, the interesting thing here is that you even have liquid water. How do you keep water liquid? Like I said, tidal heating worked really well around Jupiter, but that's insufficient here. So it probably produces a little bit of heat, but not enough. The other thing is that we know that the inner part of the moon is rock. The heavier rock would sink to the middle. Well, among the heavier things that are there are radioactive materials. Radioactive decay produces heat. So that's probably warming a little bit too. The two of these together are not enough to keep water liquid. So what would be possibly making water liquid? Well, remember, under pressure, you can squeeze it into a liquid state. So there's pressure under here. In fact, that's one of the indications here of the water that spewed out indicated that it may have been in a different form originally from just regular ocean-type water. Some indication that there's a different form of ice in here due to the high pressure. Okay, now, but that high pressure was in fact insufficient probably to completely liquefy it. So how do you keep water from freezing if you get cold? One way of doing it is antifreeze. And they realized that in the outermost part of the solar system, and remember, this is almost 10 AU from the sun, they have other sort of things that are out there, including ammonia and methane. Ammonia salts would actually make for ice crystals. Or rather, ammonia salts would act like antifreeze, rather, defeating ice crystals. And so what that suggests is that may be what's going on here. Well, that means we actually have liquid water and it's possibly salty. And if you got ammonia, you probably have methane, so you have organic molecules in here. And now all of a sudden we have the basic building blocks of life. And so, again, we look a lot at places like Jupiter and Europa, and we look a whole lot at Mars. Maybe Enceladus is another place we should be looking for life. And so that's a question here for us. And it is one of the things that we would like to really investigate is, could you have life out here? This is one reason that when the Cassini spacecraft was at the end of life, they intentionally plunged it into Jupiter, or not Jupiter, but into Saturn to destroy it so that it did not accidentally bump into something like Enceladus and contaminate it with the possibility of Earth life. I don't think Earth life would live in this environment, but you don't want to risk it. You don't want to contaminate it, because if there is life there and we find it later, we want to make sure that's life that started there, not life that we brought there. A couple other moons to talk about. Rhea, one side's heavily cratered, the other side is not, indicating some resurfacing event. It's not pristine on the other side, so it does have craters indicating that resurfacing event happened in the distant past. So maybe Rhea was doing something in the distant past similar to what Enceladus is doing now. Again, there may have been life there. It looks like a dead world now, but again, further study is warranted. Another weird moon they saw was Hyperion. It has a really weird orbit, and it doesn't really rotate. It tumbles and changes the axis of rotation all the time. And it looks like a giant sponge. We think it's mostly icy. We think it's actually mostly empty, so it's mostly hollow. And we think this is probably a comet that got caught in orbit around Saturn. And as it's tumbling, craters or meteorites, or even some of the little vents that comets typically have, the sunlight would shine into there, cause sublimation, and so every time it tumbles, sunlight would fall deep into those caverns and cause sublimation, and that would be hollowing it out, giving it sort of that spongy sort of appearance. That's just our guess. Hyperion was nowhere near as well studied here as some of the other moons. It's got a rather odd orbit, and Cassini didn't really see it all that often. But Hyperion is definitely a fascinating moon right there. And I've seen some interesting analysis, mathematical analysis of its rotational period, and it undergoes what we call chaotic rotation, in that it changes rotational period and changes rotational axis on a close to random basis. And so it just like tumbles and spirals and so forth around. I not really spiral, but tumbles and twists and changes as it goes around Saturn. So again, one of these really weird things that was completely unexpected.